Guys, Mr. Bowman here. This video is going over our 2021 Geometry and Transformations test. Make sure you've got your test right next to you. Anything you got wrong, you need to update for, you need to understand, because everything we looked at this topic may come up in our end of year exams in November, December. Okay, so let's get into our test. I'll get into the marking side of it down here at the end of the video, but let's get into the questions. So question number 1, for each of the following, what type of transformation has occurred? Answers should be limited to, and I've told you what the answer should be limited to. If you wrote anything other than that, you're probably marked wrong because you were told very precisely what your answers should be. So we'll look at the first question over here on the left. We've got the original shape coming along here, and we've got the object or the new shape coming up here. So the giveaway for me is we can kind of see it's changed orientation. So the long side is horizontal here, and it's now vertical up here. That for me is normally a giveaway that it is some kind of rotation. So that change in orientation is really important. The next one that we've got A, that's our original shape, A dash, that's our new shape. So there were a couple answers that you could actually take here. So the obvious one is translation. So we can see it goes down to and then across to. So if you wrote translation, you would have got your tick. But if you pop maybe a mirror line or a line of symmetry kind of down here in the middle, you can see reflection actually would have worked as well. So if you wrote either of those, you would have got your mark. And the key thing is you needed to get correct answer for both questions to get that achieved mark. For example, maybe you wrote reflection here. You would not have got any marks at all, even if you got this other one correct here. Okay, so that's question 1 finished. Hopefully you picked up your achieved mark here. Question number 2, reflect the following shape through the mirror line. So we've got a trapezium drawn along here, and we've got our mirror line, red dotted line going up and down here. And reflection, I think, is the easiest one. What I'm going to do is I'm going to call this here point A, and it is 2 units away from the mirror line. That means I'm going to carry on 2 units, 1, 2. That means this point up here is going to be A dash. I'm going to repeat that for all the other corners of our shape. So let's go down, maybe down to the bottom, B. So 2 units across. So it's going to be 2 extra past the mirror line. So that there is going to be B dash. We're then going to do the same, or maybe call it point C up here. So we've got 1, 2, 3, 4 units away. So 1, 2, 3, 4 units away will be C dash. And the final one up the top, point D, same thing, 1, 2, 3, 4 units away from the mirror line. We're going to go across 4 extra. 1, 2, 3, 4. That there would be D dash or D prime. Now that we've got all the points, we're then just going to connect all the points. So we're going to go down to B, diagonally up to C, up to D, and then diagonally up to A. Your diagram, like mine, it's not perfect, doesn't need to be perfect. As long as the points are in the right places and there's some kind of attempt to connect them, you would have got your achieved mark there. So that question was largely well done. It was a fairly straightforward question. So we're now moving on to question 3. Fully describe the translation below. So key thing is describe. So it's asking for a wordy type answer. So the first thing you probably need to think of is what transformations actually happened. And we can see the first shape to the second shape, it's gotten bigger, which is probably a good indication that it's going to be enlargement. Other things we need to know about the enlargement are, well, the center of enlargement. So there's the center of enlargement there. And the final thing you need to know about is the scale factor. So we should probably quickly figure out the scale factor. But what we can do is we can see the base of this shape here is 1. The base of the shape up here is now 3. So if we do the new shape divided by the old shape, that will tell you it's got a scale factor of 3. So all that information is needed to calculate or to be able to describe this transformation. So I'm gonna get into it. So Let's call it triangle ABC, and I'm calling that because that's all the corners of the triangle. You may have described that one in a different way. You might have said the small triangle or the lighter triangle or something like that. However you described it, that's all good. So triangle ABC has been enlarged. So I must state the type of transformation it is. Enlarged by a scale factor of 2. So that's really important for enlargement. You got to tell me what the scale factor is. And then I'm going to write through the center of enlargement and then I'm going to write down the coordinate of that. So that's also really important for enlargement. And that was to create triangle A dash, B dash, and C dash. And that was the description of the big triangle. You might have said big triangle, dark triangle, whatever it is you needed to. So if you included each of those elements, the enlargement, the scale factor, and the center of enlargement, that was probably enough to get you an achieved mark because it was only an achieved question for that. So there's question 3. Hopefully you came away with 3 achieved marks there, but I know there were silly mistakes made throughout that, so let's try to minimize those for our end of year exam. We're now on question 4. So transform the following by the given instructions, and the instructions must be completed in order. So what that meant was you got to do 1 first, then 2, and then 3. Okay, so let's start off with question, or part 1 of this. Translate the parallelogram up 1 unit and left 3 units. So I'm going to start off with this point here. It's going up 1, and it's going left 3. So it's going 1, 2, 3. So that there would be my equivalent point here. We're then going to do the same for this point up here. It's going up 1 and then across 1, 2, 3. There's our new point there. We'll connect those. I'm then going to take some shortcuts. Instead of translating both of these points, I'm just going to roughly do it. So it's 1, 2, 3, 4, 5 units long. So that means that there's going to be my other corner, and it's diagonally down 2 to get to my final corner. So let's connect those. We're then going to connect the ones up the top there, and we're going to connect the ones down the bottom there. So you can see that parallelogram that's been enlarged. So we'll give that a bit of, oh, not enlarged, translated. Give that a tick. We're now going to reflect shape A. Don't forget, shape A is the new shape that we've got through the given mirror line to create shape B. Reflection, nice and easy. So we're going to go 1, 2. So that means it's going to be 2 units on the other side. Same for this point here, 1, 2. We're then going to go across. This one here is 4 away, so we're going to go 1, 2, 3, 4 away. And same here, that's 4 away, so we're going to go 4 here. 1, 2, 3, 4. So let's go across here, down here, and across there. We're going to connect that. That there is going to be shape B, the reflected parallelogram. Our final one that we're going to have is we've got our enlargement, and we're enlarging this by a scale factor of 2. And this one's going to be a bit annoying. We've been given the center of enlargement, which is nice. So let's get into our enlargement. So you can see it's kind of go 1, 2, 3. So if you double that, it's going to be 6. That's going to be 3 more, which will create our point here. So let's call that A. That there would be A dash. We're going to do the same for the next point here. We can see that goes up 1 across 2. So we're going to go across a bit more. So if that's B, that there is B dash. Same for point, let's call that C. It goes up 1 and across 1, 2, 3, 4, 5, 6, 7. So we're going to go up 1 across 7 more. 1, 2, 3, 4, 5, 6, 7. So it's slightly off our grid. That's all good. And then we're going to go up 2, 1, 2. So our C dash will be about there. And finally, we're going to look at point D, which we'll call that up there. It goes let's have a look at that. So it's gone up 3, so it needs to go up 3 more, and it's gone across 1, 2, 3, 4, 5, so it's going to go across 5 more. So we're going to go up 3, across 5, 1, 2, 3, 4, 5. That there's going to be D dash. So our working's very messy, but hopefully you can see the A, B dash, C dash, and D dash. Get rid of all those, and from here we just connect the dots to finish off our shape. So there's the first part of our parallelogram. We're going to across the grid to C, diagonally up to D, and then back to A as well. So not a perfectly drawn one, but if I could see, or if your teacher could see the finished parallelogram in the right spot, you were going to get a merit mark for that. If you made a mistake somewhere along the way, but your teacher could see you did one of those 3 transformations above correct, you are then going to be given an achieve mark for that. But so if there were any mistakes, no matter how minor, you probably got achieved. But if you got it perfectly all the way to the end, you would have got yourself a merit mark. Well done. That one was a bit messy, a bit complicated, but we got there in the end. So moving down to question 5. Fully describe the transformation below. So this question here, there's 2 ways you could have gone about it. You could have started at A and gone to B, or you could have started at shape B and gone to A. Doesn't matter which way you did, you would have got your marks from the teacher. I'm going to write out my answer for that first one, starting at A, going to B. But be aware, if you did the other one, your answer will be slightly different, but your teacher should have given you the mark for that anyway. So first thing to note, we can see, if you think of it as a bit of an arrow, so arrow pointing that way, our equivalent would be pointing this way. And what that normally suggests, as above, is there's been a change to the orientation or the direction or where it's pointing. That's normally a giveaway for rotation. So here we're thinking rotation. So that's going to be something rotation. We need to mention that it's been rotated or there's been a rotation. We now need to think about the center of rotation. So we're going to need that information. This one here I thought was fairly straightforward to see. So I think I was being a bit nice with this question, but we can see if we can connect A to the origin, and if we connect B to the origin, we can see it's gone across 2 and then up 3, and then here it's gone up 2 and across 3. That there is a good indicator that 0, 0 is going to be our center of rotation. And if we're starting at A going to B, it's going towards that direction where the arrow is pointing. That there is anti-clockwise. So anti-clockwise. So that bit of information will be important. And in the middle there, that's going to be a nice right angle or a nice 90 degrees rotation. So all of that information, rotation, the center at 0, 0, the anti-clockwise direction, and the angle, all of that needs to get on up. It needs to be in the description that we're going to be doing. So let's get into it. So I'm going to call it triangle A. So triangle A has been rotated. Rotated by 90 degrees anti-clockwise around 0, 0 to create triangle B. Okay, there we go. So if you got all of that right, so rotation's a lot trickier than transformation or any of the other transformations. So to get all of that together was quite annoying, particularly finding the center of rotation. So that got you a merit mark. If you maybe got one of the elements wrong, maybe the angle or the direction or the point wrong, your teacher might have had a bit of sympathy and given you a bit of an achieve mark there. But hopefully you got the whole thing right. Hopefully that all makes sense. So there's question 5. We're now churning through these, going pretty quickly. Question 6 will go quite fast. It's a merit question. If shape B, so that's that bottom trapezium, if that's been translated to create shape A, what is the scale factor? The key thing is you've got to remember it's going from B to A. A few of us did it the other way around, which would have been wrong direction. So you wouldn't have got any marks for that. But let's have a look. So the way I think about scale factors, it's always new divided by original. And in our case, the new shape A had a base of 4, and the original shape B had a base of 8. That there was going to be 1/2. Normally, that's when you stop if it's a positive scale factor, but you can see, our center of rotation or center of enlargement's in the middle there, and it's now on the other side of that, and that tells you, well, it's actually going to be negative. So our scale factor is going to be negative 1/2. So if you told me negative 1/2, you would have got a merit. Unfortunately, there wasn't a lot of leeway. If you told me 1/2, it meant you forgot about the negative part of this, and we couldn't really give you any marks for that. There's no really any achieved marks here. You either got it right or wrong. Anyway, there's question 6. We're moving down to question 7. Question 7, give the equation that would represent the mirror line for the below reflection. So mirror line, got to think in the middle. So how I would be starting this is I would look at the points. So there's corresponding points, and in the middle of that would be the mirror line. I'll do the same up here. There's some corresponding points, and it looks like in the middle of that would be the reflection line, and then I'm really just going to connect that line. You can see that connecting there. I'm going to carry it on down the bottom. I'll carry it on the top. So that there, it's equidistant. So at this point here is diagonally 1 unit away, and it matches the other side as well. So that's the mirror line itself. Specifically, we were asked for the equation, and mathematically the equation for that is a nice easy y equals x. If you told me y equals x, your teacher would have given you a merit mark. If you got the equation wrong, or maybe you forgot how to do the equation part, but maybe you drew or described the mirror line, your teacher probably would have been a bit nice and given you the achieved mark accordingly. So question 7 done. Now moving down to question 8. So we're describing the translation that has occurred below. This is an achieved mark. Normally the case for translation questions, because translation is on the easier side of stuff. I'm not sure what's happened to the circle up here, but that didn't have a good time. Okay. So we know it's translation. We've now got to describe it, and the key idea coming out from the translation is the up and down movement with the y-axis and the left and right movement of the x-axis. So let's have a look at the points. So we'll start off at point I, and we can see it's going down 1, 2, 3, 4 units down. So 4 units down, and then it's going across 1, 2, 3, 4, 5, 6 units right. You can describe the translation with a vector. I'm not going to do that. I'm just going to use up and down, left and right language. But if you did use a vector, your teacher would have marked it accordingly. So let's get into it. So triangle ITR has been translated down 4 units. And right, oh gosh, that's not right, is it? I'll get rid of that. And right 6 units. And that was to create triangle I dash T dash R dash. If you got all of the units or all of the elements right, so you've told me it was translated and you told me it was down and right, you would have got your achieved mark for that. So we're done question 8. We're quickly getting through this test, which is really good. Question 9 will be another quick question. With a line, match the given angles with their angle types. What this is asking you to do, it's asking you just to kind of connect the ones that you think relate to each other. So let's get into it. So the first diagram here, that is a small angle. It's less than 90 degrees. Remember the small angles, they're cute because they're small, and that's what makes them acute angles. Well, that's how I remember them anyway. We're now going to look at obtuse and reflex angles. The way I remember it is if you think of this as someone's arm, you know, you got friends who might be able to extend the arm down below average because they've got good like reflexes. So that makes that a reflex angle. And that leaves the last one being an obtuse angle. And that makes sense because obtuse angles are between 90 and 180. And, you know, that's 90 degrees. That's 180. You can see that's sitting between them as well. If you got all three correct, you got achieved. If you got anything wrong, unfortunately, we couldn't give you any marks for that question. So that was question 9. Nice, easy achieved mark there as well. Question 10, estimate the following angle. This one here, my advice during the videos was just to kind of draw your quartiles. And what you can see here is we've got our 90 degrees and our 180 degrees. So we know this angle here is going to be above 90, but it's going to be below 180. What I'm now going to do is the quadrant over here, I'm going to chop it up into thirds because I thought, well, that is roughly a third. Let's see how we go. So if I chop that up into thirds like that, we can see third, third, third. Maybe this one here is slightly less than a third, but we'll see. So if that's the case, that there would be 90, that there would be 120, that there would be 150 degrees. And then that would make 180. Oh gosh, that's a bad 8. 180 down the bottom. So pretty happy with that. This here I thought was maybe slightly more than a third, so it's probably slightly less than 150. So based on that, I'm going to go for 145. But if you told me that, maybe if you were slightly less, or sorry, slightly more or slightly less, you would have been given your mark. But as long as you were probably between, I don't know, 135 and 150, your teacher would have given you some marks as well. So there you go. That was an achieve mark for that. Hopefully you remember that from the videos. So we're moving down, question 11. We're now onto the geometric reasoning part of it. So these are pretty rapid fire questions. We should be able to get through them pretty quick. For each of the following, state the angle X with justification. And there are 5 questions. The top 4 were all worth achieved. The last one was a bit worth a merit. So I suppose let's get into them. So we've got a straight line going here, and the angle chops it up into 2 parts. And we know the angles on a line, they sum to 180. So we know if we're forming an algebraic equation, x plus 115 equals 180. We then subtract 115 from both of them, which meant x was equal to 65 degrees. So you've got the answer, but that actually isn't enough to get any marks because you have to have reasoning. No reasoning, no marks. This time around, the reasoning, so angles on a straight line equal 180 degrees. I'm going to use abbreviations, but if you used full sentences, you would have got your marks. Or if you used other abbreviations, your teacher also would have given you the marks as well. But there we go. There's an achieved over there for you if you got both of those. We're now moving down to x. X is up here, and we can see by these arrows that there is a suggestion that lines up the top and bottom are parallel. These angles they're both within the train tracks, but they're on different sides, so they're alternate angles, and they're equal to each other. So here, this one's nice and easy in terms of our working. X is equal to 47 degrees, and we're going to say alt angles are equal. So that was a nice easy abbreviation. We're now moving on to the triangle question. Nice and easy. We know the sum of triangles, or the angles within them, are 180 degrees. So as an equation, it's going to be 55 plus 50 plus x. The 3 internal angles, they've got a sum to 180 degrees. That's going to result in 105 plus x equals 180. We're then going to go minus 105, minus 105. So x resulting in 75 degrees. A reasoning, interior angles of a triangle sum to 180 degrees. So abbreviations, internal angles triangle equal 180 degrees. If you're able to get 75 degrees with justification, you got an achieved mark. Our next question, this is a 4-sided shape. I suppose that's the first thing to note. And this dotted line was trying to tell you that it comprises of 2 triangles. So the sum of a 4-sided shape is going to be 360 degrees. The way you would get there, so 180 in minus 2, that there is 180 times the two triangles is 360 degrees in total, 360. We're then going to go 360, take away the other angles, so 360 minus 95 minus 123 minus 62. That there gives you your angle. It gets us to a total of 80 degrees. Our reasoning for that, a few different ways you could explain it, but I'm going to say interior angles, four-sided shape equals 360 degrees. If you got me all that, you would have got an achieved mark there. Those were your 4 achieved marks that I mentioned earlier. We're now going to shift down to the merit one down the bottom. This one's a bit trickier because there's 2 steps. So what I would have done is I would have labeled another angle. So I'm going to call that angle Y. You may have done this angle up here. Regardless of which combinations you've chosen, you should get to the same final answer as me, but your reasoning or your justification may be slightly different. As long as your justification made sense, your teacher would have given you the marks. So let's go through in mine. So I know that Y is equal to 121 degrees, and that's because vertically opposite angles are equal. And I now know that the angle up the top here, this big angle, is corresponding to Y. So I know Y is going to be equal to X plus 50, and that's because corresponding angles are equal. And here I'm just going to do a bit of algebra to figure that out. So Y is 121, so 121 is equal to X plus 50. So we're going to go minus 50 minus 50. So X, in this case, 71 degrees. And I've got my 2 reasonings from my earlier steps as well to support that. If you got me both answers with some reasoning, you would have got a merit. If you made a mistake along the way but had some kind of correct angle and reasoning, your teacher would have given you an achieved mark, but hopefully you didn't need that and you just got the M straight away. So we've done all those ones. We're shifting on to the Australian coin. So the Australian 50-cent coin is a regular polygon. We've been asked to determine the interior and exterior angles of the coin. With justification and working, our answers should include full geometric reasoning. So first thing you needed to do is you need to count how many sides does this coin have. So I would have gone 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we've got 12 angles. I'd probably start off with the interior angles because they're just easier to look at. So the interior angles, it's going to be 180 n minus 2. That's our formula. That there will be equal to 180, 12 minus 2, which is equal to 1800 degrees. That's our total. Within what we need to do is we need to chop that into 10, also to 12, because that 1800 degrees is going to be equally divided between the 12 angles because they're all going to be the exact same. So we're going to go, I've got my calculator with me, but 1800 divided by 12, that gets me to 150 degrees. Hopefully you got the same there, 150 degrees. So that's our interior angle. In terms of our reasoning, you probably want something like total angles in 12-sided shape equals 1800 degrees. And then that last step, if it's a regular polygon, all the angles equal. So internal angles in a regular polygon are all equal to each other. So your reasoning may be slightly different to mine. That's all good. No dramas with that. We're then going to move on to the exterior angles. And I do have a note. A few people did make some mistakes here. So if you look at 6 and 7 down here, so our interior angle there would have been 150 degrees. If you're telling me this angle down the bottom is the exterior angle, that is incorrect. That meant you didn't really understand the definition of an exterior angle correctly. the exterior angle is if we carry this side onwards, and we're going up like this, it's that angle that would have sit in between there. So in our case, that there would have been 180 minus the 150. So our exterior angle is 360 degrees. You might have also done 360 divided by 12. That would also have gotten you to the 360 degrees. Depending on which one you did, this one here was the angles on a straight line equal 180 degrees justification. And this one here would have been exterior angles of a polygon equals 360 degrees. So if you got me both numbers, 30 degrees and 150 degrees, with sufficient reasoning, you got a merit mark. If you did something weird or something odd on the way, maybe you didn't justify the reasoning enough, maybe you did a math error somewhere, your teacher probably would have given you an achieve mark because of the skills you showed despite the mistakes. So there's question 12. Let's move on. We're now on to 13. And very specifically, this does say using algebra, determine both angles. And key thing is both. Your answer should include full geometric reasoning. So I'm going to start off with my reasoning. It's nice and simple. Angles within a right angle sum to 90 degrees. So that there's nice and easy. So in terms of my maths, I know the pink angle, 2x plus 46. And we add on the green angle, 30 or 3x minus 6. Both of those angles combined have to go to 90 degrees. I'll get rid of the degree sign. We're then going to use algebra, so it's going to be 5x minus or plus 40 equals 90. We're then going to go minus 40 minus 40. 5x is equal to 50. X is equal to 10 degrees. So a few of us did stop at the x part of it, but you haven't actually calculated any of the angles. So if you stopped there, your teacher would have been a bit nice and probably given you an achieve mark. However, there's a bit more work we need to do. We've been asked to find the angle of both sides, which we're going to do that. So I'm going to do my work in over here. What I'm going to do is I'm going to substitute in the 10 that I've calculated. So that there would be 20 plus 46. So that means that pink angle there would have been 66 degrees. I'm now going to do the same for the bottom here. So that's going to be 3x minus 6. That's going to be 3 times 10 minus 6, which is 30 minus 6, which is 24 degrees. If I got both of the degrees, 66 and 24, that's what your teacher was looking for. In addition to your reasoning, you would have got the nice merit mark for that. So we're running to the end of our test. We've only got the 2 excellence questions. This video is certainly a lot longer than I thought it was going to be, but I guess there's a lot to explain here. Question 14 was quite a challenging one to mark for all the teachers, and that's because just a lot of us showed good geometry skills, but we didn't read the question. But our question specifically says, form an expression for angle y in terms of x. So a few of us just went to calculate angle y as a number, but we were not asked to do that. We weren't asked to do that. We wanted an expression in terms of x to do that. So let's run through and we'll go that. So the first thing I want to note is, let's say we had maybe angle here, angle A. You can see by the dashes, all 3 angles or all 3 sides are going to be the exact same because it's an equilateral triangle. So that's our first geometric reasoning that I would have done. So angle A is going to be equal to 60 degrees, and that's because internal angles of equilateral triangle equals 60 degrees. So that's our first step. I've got my answer with my reasoning. And what that tells us now is, if you think of this big angle here, that there is going to be x plus 60 degrees. So we're going to move on to the next bit. So we're going to move on to angle B here. So angle B is vertically opposite to the A and X. That means they're going to be the same. So angle B is going to be equal to x plus 60 degrees. And this is where the expression part of the question I'm talking about comes into. I've not got numbers, I'm now looking and using at x. So there we go. And that's because vertically opposite angles are equal. You may have done slightly differently. You may have gone down here for angle B and used corresponding angles to get that. I'm happy either way, as long as your reasoning made sense and supported that decision. Okay, so I'm now going to jump down to this bottom angle here, angle C. Angle C, that's also going to be equal to x plus 60 degrees, and that's because they're corresponding angles. So, corresponding angles are equal. So we're getting there. I'm now going to move on to angle D down here. So this shape, we can tell by all the double lines, is a regular polygon. All of the angles of a regular polygon are going to be the exact same, which means C and D are going to be the same. So angle D is also going to be x plus 60 degrees, and that's because internal angles of a regular polygon are equal to each other. So I've written that in a full sentence. You may have abbreviated that to make that a bit quicker. That's all good. And the final one, we're now up to angle Y. This is what the question's been asking us all about. Angle Y. If you think about it, angle D and angle Y, they're both on that straight line, which means they're going to sum to 180 degrees. So if we go 180 minus angle D, that leftover amount should be angle Y. So let's expand the bracket. So it's going to be 180 minus x minus 60, which means 120 degrees minus x is equal to angle Y. And that there is the expression we were looking for. So a few of us were telling me something like maybe 72 or 108 degrees. They were getting the exact numbers, but that's not what we're interested in. And our reasoning, angles on a straight line equal 180 degrees. So if you got all the way to the end with lots of reasoning, your teacher, hopefully they didn't give you a merit mark, but you would have got your excellence mark. If you showed us some skills, maybe you're using the 72 and 108 instead of the x. So maybe if you're using 72 and the 108 type answers, probably were given a merit because you showed some really good geometry skills, but you didn't quite get the question. Maybe you didn't really flow through the question too much, but you showed us some basic geometry skills, you would have got your achieve mark for that. So that's question 14. And we've now got our final excellence question. We've been asked to explain whether AB is parallel to CD and whether CD is parallel to DE. So first thing is we've got the arrows on the two lines going horizontal. That tells us that these here are parallel lines. And we're trying to check if initially AB and CD are parallel to each other. So that's our first step that we're trying to find out. So what I would be doing is I would be calculating the angles within the shape just to try to get some more numbers. And I can see that this triangle here, so triangle BCD is isosceles. So that means 180 minus 30 divided by 2, 75 degrees. That tells me the base angles of that isosceles triangle. So base angles of iso triangle are equal to each other. So I've now got that. I'm going to have the same things for the angles down the bottom. So that there is going to be 75 degrees, and that there means x is going to be 75 degrees. So x is going to be equal to 75 degrees. And the same logic, base angles of isosceles triangle are equal to each other. And that means the angle up the top there is going to be 30 degrees. And I'll just write my angles in triangle equal 180 degrees. Just you can see that 30, 75, they're coming up everywhere in our diagram. So the same logic would apply here. That part of the isosceles triangle is going to be 30, down the bottom, 75, down the bottom here, 75 degrees as well. So we can put that everywhere up there, 75 degrees as well. So I'm not going to state my reasoning for that, but we can kind of see the pattern, the sequence of triangles within the parallel lines. There's going to be a lot of 30s and a lot of 75s coming up. So what I'm now going to do is I'm just going to change in color just to emphasize something. So we're going to start off by proving AB is parallel to CD here. And you're looking for your bisecting line, which would have been BC. And what you can see is if you're looking at the angle here, that's 30 degrees. If it was parallel to the other line, the corresponding, or the angle on the other side, or the alternate angle, should also be 30 degrees. We'll get into our logic. So if B or BA is parallel to DC, the parallel line rules, parallel line angle rules should apply. So that's my big statement. So we're not sure if they are, but if they are, the angles should be matching each other. And what we can see is we can see the 230 degrees matching each other. So what we know is, we know angle ABC. So that's the first 30 degrees. That's the same as the second 30 degrees, which I'm going to call BCD. So that there is 30 degrees. Angle BCD is also equal to 30 degrees. And these are alternate angles. So they're alternate angles. And they're equal. Which is a property of parallel lines. And that leaves out, therefore, we can say line AB is parallel to line, CD. Oh, there you go. I'll write there around DC. And I just realized I made a mistake up here. That should be DC as well. There we go. So that was the first lines. We're now going to do the same for another set of lines. So let's change pen color again to make it clear to see. It's not particularly clear, is it? So we're now going to check the other ones. So BC and DE. So BC is over here. And then DC is over there. Same logic. There's the bisecting line. And what we can do, we can see 30 and 30 coming up again. So I'm not going to rewrite the whole instruction again, but for the similar thing. So we're now going to be discussing BC and DE. We're also going to be comparing those 30-degree alternate angles. And that there is our proof that those lines are parallel. So you should have done a better job than I did with my explanation, but I'm just taking a bit of shortcuts for the video's purposes. So if you're able to show me some reasoning to get those blue angles, and then explain and justify why BA and DC are parallel, and the same for BC and DE, you would have got an excellence mark from your teacher. If your answer was like on the right track, but maybe it was lacking some reasoning or it wasn't convincing, your teacher would have given you a merit mark. If maybe you didn't really get into the question, but you showed some of those basic angle properties that we were looking at in the earlier questions, your teacher would have given you an achieved mark. So that was the whole test. If we scroll up to the top, it does give us instructions about what we needed to do for each mark. So for achieved, you needed to get 5 achieved marks. If you got those 5 achieved marks and then that was accompanied by 4 or more merit marks. That's how you got into merit. And then finally, if you got one of the excellence marks on top of that, you would have got your E. Both excellences means you're very, very good at geometry and transformation, so well done on that. And you also would have got your EA to support that as well. So guys, thanks so much for watching the video. Hopefully you've updated everything that you've got wrong. And just a reminder, all this stuff is going to be coming up into end of year exams, which will be here before we know it. So make sure we're reviewing this and make sure we're enjoying our next topic as well. See you later, guys.